In some ways, the processes of memory are like a computer. Like a computer, when you write your paper it doesn't actually store the little letters or the words on your hard drive disk or the cloud. It encodes the information onto the disk. And there are three types of codes that we use for memorization. They are visual, acoustic, and semantic. So take a look at the letters on the screen and try to remember them. So you may have tried to remember those letters visually, using a visual code, meaning you may have tried to keep a mental picture of the letters in your mind. Or you may have tried to remember these letters and would read the list to yourself and repeat it several times, either loudly or silently. And that'd be an example of an acoustic code. Or maybe you may have even tried to remember these letters by attempting to make sense of them or to figure out what they mean. Maybe you tried to find a word that begins with each of the letters in the list and then make up a sentence using those words, like only tiny tots feel friendly, etc. This way it may be easier to remember the phrase other than a bunch of random letters. Remembering it this way would be hard, but if I were to tell you that each of those letters stood for the first letter of the series of numbers from 1 through 10, you probably wouldn't have forgotten. Also, like a computer, if we want to store the information we receive, we have to save it to the hard drive or store the information in our brain. With the computer, however, we must tell it to save. With us, we store the new information using a variety of different ways or strategies, and these are very similar to the ones we use in encoding. But in storage, we're maintaining the encoded information over time. So maintenance rehearsal is when we repeat information over and over again to keep from forgetting it. The more time repeating and rehearsing, the longer it will stay with us. An example is when somebody gives you their phone number and you don't have your phone or piece of paper nearby. Actors and actresses also rehearse their lines again and again until they know it as well as they possibly can. Elaborative rehearsal is a much more effective way of learning, where you relate new information to old information. For example, if you take Spanish, you may be encouraged to use the new vocabulary words in sentences instead of just repeating them over and over again. And just like in a computer, you store information in files, and sometimes maybe those files have files. And in this way, memories become stored and arranged in your mind for future use. So for instance, when you think of animals, you may go into your animal file and choose a file labeled birds, and within the birds file, you may recall the names of several different types of birds. Your brain organizes objects according to common features. With retrieval, the third process of memory, again, it's like a computer. In order to retrieve information that's stored in a computer, we have to know the name of the file and the rules for retrieving that information. We need similar procedures. Some information we know so easily that it's impossible to get, like friends or family's names, but some information, such as mathematical formulas, may be a little bit more difficult to access, so we have to use some of those codes. Remember the group of letters that I gave you earlier? What were they? You used a semantic code to remember, and that's what we sometimes have to do in order to retrieve information that's in our long-term storage. Have you ever been to a place that brought back old memories? Maybe you went back to the elementary school or to the a neighborhood that you used to live in, and it spurred your memory. This is called context-dependent memory. Some memories are dependent on the place or environment where they are stored. If you don't return back to where they're stored, maybe you would never remember them again. In this way, studies have shown that students do better on tests when they study for the test in the room where the test will be given. And one last thing regarding context-dependent memory. In a trial, some lawyers will ask a witness to describe a crime. They ask the witnesses to describe the scene as clearly as possible, and police will sometimes even take witnesses to the scene of the crime in hopes that the visit will improve their memories that they witnessed. Not only do people tend to retrieve memories better when they're in the same place they were the first time they store memories, but people also retrieve memories better when they are in the same emotional state that they were in when they first stored those memories. And those are called state-dependent memories. An experiment in 1981 gave people a list of words to memorize when they were in happy and sad states. And they found that people who were in the same emotional state they were in when they learned them did better on those tests. And not only is memory better when people are in the same mood when the memories were acquired, it's also better when people are in the same state of consciousness. That is, things that happen to somebody under the influence of a drug may actually be remembered most accurately when the person is back under the influence of that drug. And just like we have processes of a memory, we also have stages of memory. The first stage of memory is sensory memory. It's the immediate initial recording of sensory information, and it only lasts about a half a second to 2 seconds, but we have an unlimited capacity. A memory trace of a visual stimulus held in our sensory memory actually starts to decay within a second. So if we want to remember it, we have to do something with the information really quickly. And there's two different types of memory traces, iconic and echoic. And iconic memory is a part of our sensory memory that holds our visual memories. Things are seen, then they disappear rapidly, and they don't stay in our iconic memory longer than 1/10 of a second. Or echoic memory, which is a momentary sensory memory of an auditory stimuli. And these are all the things that we're seeing or hearing at any given time. Things are always happening in our sensory memory, but the things that we pay attention to are the things that go into our second stage of memory, our short-term memory. Short-term memory is memory that holds information briefly before it's stored or forgotten. We actually use our short-term memory a lot. Whenever you're thinking about something, it's in your short-term memory. When you're listening to this screencast right now, it's in your short-term memory. And when you're trying to solve a math problem, the elements of that problem are in your short term, and sometimes because of this we call it our working memory. When you meet someone new, you put the person's name in your short-term memory, maybe by using the same name or by repeating it to yourself several times. When you're told a new phone number, you can't keep it in short-term memory by repeating it over and over again. But repeating the number will give you time to look for a pen and paper. Information in your short-term memory begins to fade after several seconds, and if you want to remember it longer, you need to keep rehearsing the information or take other steps to prevent it from fading. So let's try an experiment. In a moment, I will show you a list of words, and you have 15 seconds to remember as many as possible. Now write down as many words as you can remember. Chances are that you had more difficulty remembering a specific section of the words, whether it was the beginning, the middle, or the last. Sometimes the middle will be more difficult to remember, and these effects have names. First, the primacy effect. The primacy effect is the tendency to remember just the first items in a series. So for instance, if you only remembered the first 5 or 6 words, or maybe even the first 10 words, you are experiencing the primacy effect. The recency effect is the tendency to recall the last item or items in a series. So if you only remembered the last words, then you are experiencing the recency effect. If you remembered the words at the beginning and you remember the words at the end, but you were missing out on the middle section, then you are experiencing both the primacy and the recency effect. And often it is more difficult to remember items that are in the middle. One way we can prevent this from happening is through a process called chunking. If we think about the way that phone numbers are set up, we don't just give a list of 10 numbers. It's actually easier for us to remember these numbers in smaller chunks because it's in smaller units. So instead of having to remember 10 separate numbers, now we really only have to remember 3 or 4 numbers. An experiment in 1956 actually found that the average person can only hold a list of 7 items in their short-term memory. And generally, the rule is 7 plus or minus 2. Some people can only remember 5, some can remember up to 9. But our short-term memory can really only hold a limited amount of information at a time, and then interference can happen. Our short-term memory sometimes is like a shelf that holds only so much information. Once a shelf is full, you can't put something on it without shoving something else off. There's actually an experiment in 1959 using college students to prove this theory, so let's try it. I'm going to give you a group of 3 letters to remember. Don't write them down, but in about 5 seconds, I'm going to ask you to recall these letters. Ready? WTH. Can you recall those letters? Good. In the college experiment, nearly 100% of the students recalled those letters. Now how about this? I'm going to give you another set of letters for you to remember. When I say the letters, you're going to start counting backwards from the number 142 by 3s silently in your head. So for example, if the number was 156, you'd start with 156, 153, 150, 147, and then repeat it silently. So ready? The letters are Z, B, T. Now start counting backwards from 142 by 3s. In the college experiment, about half the students forgot the letters. Continue counting. And at that point, nearly all students forgot. 18 seconds actually seems to be the number of seconds that most people can hold information in their short-term memory. Our short-term memory is very useful. It allows us just enough time to find a way to store the information more permanently. Short-term memory is the bridge between our sensory memory and the third stage of memory, our long-term memory. The final stage is long-term memory, and this is a big one. This contains more information than an encyclopedia or a computer's hard drive. It holds names, dates, places, the memory of how I was picked on in kindergarten, or the look on my father's face when he found out I crashed my car in high school. It contains more words, pictures, sounds, smells, tastes, and touches than you can count. Information is constantly being transferred into your long-term memory. It's estimated that a person will have stored roughly 500 times as much information as can be found in all the volumes of the Encyclopedia Britannica. There's no limit that researchers have found to how much can be stored in our long-term memories.